Okay, well, thank you very much for the introduction. As was mentioned, I'm Barnaby Osborne. I work for the European Space Agency. In particular, I hold the role of being the Small Satellite Technology Coordinator within what's called the ARTES program within ESA. And the ARTES program is the one that focuses on telecommunications and funding and supporting industry within the telecommunications sector. So my role is I look after the very small satellites within this sector, which puts me at odds with quite a lot of my colleagues because, as most of you know, telecommunications satellites are rather large, and they look at our small satellites, our CubeSats, and often with a slight smile on their faces. But what I am here to tell you, though, is that the small sat sector is getting big. Okay, and we recognise that at ESA. And for the last year or so, we've been looking and examining this particular sector, looking at what it is proposing, what is coming up in the future, what the challenges are, and what, in particular, problems it can solve within telecommunications. Before I go into that, I will just preface this presentation and say that it is aimed at the commercial sector. Mostly because telecommunications is where the money is being made within the space sector. So most of what we try and support and what we try and get out at the end supports the commercial satellite industry. Not to say that the academic and the amateur side does not play a role. In fact, actually it plays an important feeder link, as it were, into this particular sector. And we rely very much on the developments that are being done at these levels that then create the future technologies. Okay. So I'm going to start with a couple of definitions, according to us anyway. So first presentation of the day, and I'm sure none of you heard what a satellite is before, so that's fine. For the benefit of those who haven't, I'm going to define what a small satellite is and take the most robust resource possible, which is Wikipedia, and say that yes, small satellites are small miniaturized satellites, low mass, low size, usually under 500 kilos. Now within our sector, 500 kilos actually incorporates quite a large number of satellites, but still not some of the big GEO birds that we fly, which are up in the many tons. When you look at one of those satellites, you can try and throw some acronyms, and not acronyms, sorry, adjectives, to describe them out there. And what falls out very, very quickly is that they are small, yes, okay, it's in the title. They're quick, and they're typically low cost. These are the three defining characteristics that we pay attention to. And in particular, the combination of those adjectives create all sorts of interesting capabilities with these small sats. So because they're quick and small, it means that we can usually develop them very agile, in an agile way, and launch them in a short time frame in comparison to other missions. Because they're quick and low cost, it has implications on the development process. It means that the companies that are dealing with them usually have to adopt different processes to what we're used to in the space industry. Because they're small and low cost, it also means that they're accessible to the new players in the sector. And in fact, when you look across the board, and I've got a slide on this later, you'll see that about 90-95% of people who are involved with small sats are new, small, medium to size enterprises. They're people with a good idea, they're developing their satellites in a garage, and they're launching it, doing first proof of concept flights. And this is good, but it also presents a challenge to us in the agency, where we have developed all sorts of tools and mechanisms to deal with the large primes, developing large satellites on a large timescale with large budgets. So we are constantly innovating our particular tools of support to try and support these types of smaller, more agile, innovative companies. On the right-hand side as well, we've got kind of the slightly hazy definition of what a small sat is in terms of physical size. You've got our nice little guy Fred here, and you've got CubeSats next to him, you've got mini-sats, microsats, and then you've got the kind of largest satellites that we launch. So it gives a nice kind of frame of reference for how big we consider a small sat to be. Again, a couple of definitions of the sector. So small sats, they do get subcategorized into different terms, everything from mini sats, which are up to the 500 kilo class, down to femtosats, which you might be familiar with things like chipsats or little PCB sats. And they're everything in the middle. But they are, they incorporate quite a range of different satellite sizes, and also they incorporate quite a large number of the satellites we launch every year. So if you have a look at the plot here, you can see the number of satellites launched, and this is slightly out of date by about 12 months. Plot that shows that we're launching roughly about 300 satellites each year in this type of class. Now, just to kind of give you an indication, we're typically kind of only launching around about 350 satellites in total. So small sats represent the majority of satellites that we launch out into space, ish. Okay, so they shouldn't be ignored necessarily just on numbers alone. And this plays a particular role in terms of kind of regulation and management of these. So we have a large group of satellites that are being launched. They don't represent, however, the amount of launch mass we put into orbit. So the majority of things we put into space, okay, in terms of kilos, still the big satellites. And they go to either GEO or MEO or LEO. Okay, speaking of which, where do we end up putting them? Okay, historically and traditionally and currently, however you want to phrase it, small sats go to LEO. Typically, they go into sun-synchronous, what are called sun-synchronous low Earth orbiting altitudes. So this is in a band which is maybe 600 kilometers up. Okay, takes about 95-ish minutes to orbit round in a near polar orbit, and they cover a large proportion of the Earth's surface. Now, why do we put them there? It's an interesting question. We tend to put them there out of convenience because small satellites are typically secondary or piggyback payloads, and they go on the larger satellites launch opportunities. And those large satellites like to go into sun-synchronous orbits because if they're an Earth observation satellite, then it gives them excellent coverage of the Earth, and it also has so there's quite a lot of opportunities to go out there. Having said that, when you look at telecommunications, though, where do we tend to want to put telecommunication satellites? Not necessarily into sun-synchronous low Earth orbiting altitudes. Actually, quite a large number of our telecommunication satellites live out in the geostationary band. And historically, we haven't done that with the small satellites. There are a few interesting proposals to put small GEO platforms out there. When there was a small GEO platform study done within ESA, our systems engineers got hold of it, and suddenly it wasn't really that small anymore. It was about 1,200 kilos. So it is actually somewhere where we don't tend to go. And this raises a kind of interesting open question, which is why don't we put small sats out into GEO? If that's where the money is, if that's where the market is. And that is a question that we're still trying to address. There are all sorts of technical reasons. When you look at orbits, LEO is a really, really nice place to put satellites. Okay, it's kind of like it's like the Bahamas of orbits. Okay, it's relatively low radiation. Okay, it's close in, so you don't need high powers for transmission to be able to communicate to your satellites. It takes less energy to get out there, so it's quite cheap to go there. And also from a public perception or a regulation perception point of view, it's quite passive in terms of end-of-life procedures. When you put a satellite into 600 kilometers or less, it will come down regardless within a certain time period. When you go significantly higher, you've got to start getting smart with your satellite and trying to dispose of it in a nice, socially responsible way. When you go out into medium Earth orbits and geostationary orbits, things get a little bit nastier. It gets more expensive to go up there. You have to have larger payloads and larger power supplies and solar arrays to generate your power to be able to communicate the same amount of information back down to ground. The radiation is more intense. You have more failures in orbit, and in particular, if you get out into GEO, we have what's called the GEO, or the protected zone in geostationary orbit, where we have to have actual reliable and tolerant methods of disposing of a satellite in orbit. Okay, 98% reliability in your end-of-life disposal, which at the end of a particular mission might be really, really tough to do on a small platform, because you've got to build in extra redundancy and so on. And that's why, you know, when we did a small geo platform study, it suddenly got bigger and bigger and bigger. Again, am I back? Yes. Okay. So, small sats live in LEO, typically. The money is made outside of LEO, almost predominantly. So there is now an opportunity for maybe looking at putting small sats in different orbits. I'm going to take a step back and say, not talking about small sats now. Let's just examine the telecommunications market for a second, okay? Because that's quite useful. I mean, why do we put things into space, for a start? One, because it's fun, okay? That only gets you so far and doesn't really pay the bills. Two, because we can make money, okay? And three, because it advances our science, technology, and the human race in general, okay, esoteric reasons. I'm going to concentrate on reason two, though, okay? Because we do need to make money to be able to do this. When you look at the satellite industry, so these are figures from earlier this year, we make around about $360 billion in the global space economy. Roughly a third of that is in ground service support, so ground terminals, networks, distribution of data, and so on. About a third of that is in satellite services, providing the actual information from space. And this is where it gets interesting. Okay. And the rest of the third is all kind of the other stuff we do in space, like putting astronauts up there. Okay. I'm not so concerned about that. So, a third of the money to be made from space-generated space data, okay, is what makes up the global space economy. When you break that down, out of that, the big money is made in television, radio, broadband, fixed, mobile, and about $2 billion in remote sensing. Okay, so about, what is that? 95-ish% is made in telecoms. Okay, not to blow our own trumpet here, but yeah, telecoms is good. Right? It pays for the space industry. When you look at that, almost all of that is television, broadcast television. Now, I've got a colleague, Phil Haynes, who I don't know if you've ever seen one of his presentations. He's called the fifth horseman of the apocalypse. And he presents every year about the global decline in television broadcast. Okay, and yes, the figures back it up. What we're seeing is a 10 to 20% relaxation, I think is the polite way of saying it, in the air broadcast market, where people are going away from traditional Sky TV broadcast and going to peer-to-peer television on-demand services. So we're seeing that big figure, the big 95 billion, 94 billion, relaxing by 20%, which is actually quite a lot of money going out of the space sector. And the question is well, okay, what's going to happen? You know, is the market going to shrink? Are we just going to launch less satellites? Or is something going to supplement that? And there are some hopes for 5G, there are some hopes for LEO broadband or broadband data services from space. And these are things that are in the future. And the good thing, well, I'll get onto that, where small sats can play a part in that. Okay. Again, just dissecting telecommunications and small sats. So we did a kind of a rough internal survey. In terms of all of the activities at ESA we're involved with small sats, we broke it down by, and the ones we're aware of, by nation. And roughly a third of activities in terms of by companies participating in this are in Europe, about a third are roughly in the US, and about a third are roughly elsewhere. It's a nice global spread. Everybody's doing this, and this reinforces one of the important points about small sats in telecoms, which is it's accessible. If you've got a good idea, you've got a couple guys, typically a beard and a suit, so beard being the technical guy, a suit being the salesman who can get investment, you can start up a business in small sats. Okay? This is not necessarily comprehensive, fully correct, and so on, but it does give a nice, good snapshot. And we are seeing a slight global trend actually now where the big primes are starting up and doing activities with small sats, CubeSats, tech demos, and also service provision. But it is still an industry that is dominated by the small guys. Okay, again, I'm just going to dissect the industry a little bit more. When we looked at the application use, or the users that predominantly used small sats in the past, we saw that it was roughly half commercial and then half civil, so academic. So lots and lots of universities were launching lots and lots of satellites. Commercial was, saw the need, and there was some good constellations being launched in the under 500 kilo class. The prediction, though, for the next 5 years is that it's going to predominantly be commercial satellites. We're going to see that either the market is growing or the percentage number of academic missions will be eclipsed by the commercial missions. And when you have a look at the databases of registered launches and intent to launch, you see this, and you see huge numbers of 100, 200 satellites being launched for a single company. And this is what's driving this particular trend. So we're seeing a large number of future commercial small satellite missions coming up. And I want to emphasize this is in the future. At the moment, we don't have huge constellations of small sats up there, bar roughly two examples, Spire and Planet, both of which have in the order of 100 satellites in orbit. But in the future, we do see lots and lots of planned, what we call mega constellations or large constellations of satellites. Also, if you have a look at the applications which they're targeting, predominantly was Earth observation, EORS, Earth observation remote sensing. Dominated the market around about 60%. And communications was only 4%, which made us feel rather small. This is a presentation that was, first developed to convince my bosses that I have a relevant job within the agency. And you can see that in the next 5 years, though, we're going to grow that market from 4% to 22%. So that's actually quite a large market grab in terms of the applications for these small sats. And this is real growth as well, because we're seeing the number of launches going up as well, the number of satellites going up. So this is not necessarily the market shrinking and adjusting and so on, and communications remaining the same. This is lots and lots of more small communication satellites going into orbit. Okay. Now, just having a quick reflection on what we do in space with communication satellites. Most small satellites that go into orbit, okay, with the exception for Starlink's, LeoVantage and OneWeb, okay, I put that disclaimer out there. So most by number are LEO constellations or future constellations, and they target what is called the Internet of Things or machine-to-machine services. Now these are data services which are low data rates. They require low transmission and reception powers. They are latency agnostic. Okay, so it doesn't matter how long it takes necessarily for your message to get from A to B, as long as it gets there eventually, kind of. Well, maybe you can repeat it a couple times. Okay, and there's also a low service reliability required in comparison to other data services. This is great, and this fits the capabilities of CubeSats really well, and small sats, because we don't have huge amounts of power. We don't have huge amounts of area to put big deployable antennas. We don't have massive amounts of mass to put on our spacecraft for attitude pointing to be able to control and point these antennas very, very accurately. But we can very cheaply put up an SDR with a small deployable antenna and communicate with a little device on the ground. So that's good. So there is a niche there. Now, there are lots of projections on the size of the IoT and M2M market. And one of the challenges that I'm going to put out there is, it's an open challenge, okay, is how much of that market can small sats grab and secure? Now, it's not necessarily an obvious or easy thing to answer, because the IoT and M2M market, I think, was valued at one point at around about 5 billion, okay, of which satellite services provide only a segment of that. But even if it's $1 billion, now, if there's $1 billion market out there, and you've got a couple of CubeSats servicing that, or even lots and lots of CubeSats servicing that, my question is how long is it going to be a viable business case before one of the large incumbents puts a little hosted payload on one of their geo platforms and does the same thing? Is there anything within the small sat platform that protects them from that type of incursion by the big players? Yes, perfect. Okay, so they can respond to changing markets, and actually that's a really key activity. Although, you know, arguably the big guys are actually able to respond fairly quickly as well, especially when it comes to hosted payloads. My concern is that I can't actually see anything that protects the small guys, the small satellites, from being able to capture and secure this market. And this becomes something that we concern ourselves at the agency quite a lot with, because we see business plans, propositions for businesses which build themselves on being able to say, right, we're going to capture that market because nobody else has. Okay, that's true. Nobody else has put the investment, the capital expenditure in place to be able to create that service. But our concern is that once they've proven that market, the big guys will come in and go, oh, well, thank you. You found yourself $1 billion market. Excellent. We'll take that. Yeah. So, yes. Yeah. Yep, that's exactly right. There is very little. I mean, you can't rely on the big guys for, you know, being kind to you. Okay, if there is a market, if there's a proven market, then that's fine. In fact, what we're seeing is that we see they're purposely hanging back and saying, right, you go off and you investigate this. Is this a viable market? And once you've done that, we'll step in. Thank you very much. Okay. So, as a proponent of small sats within the agency, my role is then to say, well, what is the point then of these small guys? What can we do? And actually, if you then look at the developers of small sats and small sat applications, if you see them as being kind of the frontier pioneers and going out there and proving these new markets, that's fine. That's actually a viable business case. You can have businesses which have short-term returns. They can close their business case within 5 years. They don't have to rely on having a 20-year business, capturing a market and holding that market. They can be serial inventors. And actually, that's something that we think is a real advantage of small sats, and it comes back to this agility. It's the ability for these small, agile companies to take a new market, prove it, make some money, and then being able to exit quickly and start again. Okay, fine, they don't get the nice kind of relaxed period where they rake in the money, they buy the Ferraris and their second houses in France and so on. And it makes for quite a dynamic lifestyle. But that actually is what we see, I think, is the strength of the small sat guys. Okay. Now, this is a slide that I put together specifically to combat my colleague Phil, who has a very dim view on whether or not small sats ever make money. If you have a look at new space investment at the moment, what you're seeing is huge amounts of money being invested, $18 billion invested in new space technologies. It's broken up into launches, but mostly it's into startups with small satellites. What we have seen in terms of return on investment is very, very, very little. If you have a look across the market, you look at the big guys like Spire, Planet, and so on. Have they made money? Nope. Have they burned an awful lot of investment getting there? Absolutely. Okay. Does that make us really, really uncomfortable and some of the investors quite shy? Yeah, it's getting a bit that way. Okay. But this is meant to reassure people a little bit, which is on the right-hand side, what we have is we have a typical new technology development curve. And it is, or investment curve in new technologies. And it is characterized by large amounts of investment to start with. So that's the blue red lines here. And a lagging return on investment, which is good, okay? And it means we just got to have confidence. We've got to stick by these guys. It also means that at the agency, we have a role to play to be able to support that early investment without relying on a return on investment initially. Unfortunately, the differentiator between investment in new technologies and a tech bubble curve, it's really hard to pick, okay? So there is possibility that we may see some massive failures within the industry, and that will have ramifications across the board. But at the moment, we are maintaining a certain level of confidence and optimism, I will say, that these investments, not all of them, but a significant amount of return will be generated on these investments. And we have a good degree of confidence, actually, that small sats represent quite a large future potential market. And at one point, we started trying to characterize what is that market, okay? And we kind of gave up because trying to predict future markets and future disruptive markets with these small sats, it's almost, it's a mammoth task. And we turned around and said, well, actually, it's not really our role. Our role is to try and see what everyone else comes up with. And we can assess those and see which ones are good ideas, but we're not going to be the idea generators necessarily. Okay, so small sats are not necessarily all doom and gloom. They're not necessarily lots of investment, no return. They may have a commercial point. What do we do within ARTES? So when I speak of ARTES, I'm talking about the telecommunications part of the European Space Agency. So we have a goal. Our goal is to increase competitiveness of space industry within Europe. Okay, telecommunications space industry in particular. And I've just added in 3 words there, which is small satellite businesses. Okay, so I've made a sub-goal of ARTES. So we're here to promote small satellite telecommunications businesses within Europe. That's important. If somebody's doing it in the States, I don't really care so much. Okay? And in fact, one of the good ways of working with ESA is to take a really good idea being done in China or in the States and just reproduce it here in Europe. Okay? Because that makes us more competitive, globally speaking. When you look at small satellite businesses, it's typically made up of providers of space, ground, and system segments, aggregators or space mission providers, or support and consultancy services, or satellite services. And I've underlined that one because that's where hopefully the majority of the money is being made. When we did an analysis on the satellite services market, though, we saw that it was actually not really easy to work out what it is for small sats. It's a fragmented market, heaps and heaps of different ideas. Okay, there's some groupings, but there's people doing everything from space billboards, where you see visual displays going across your sky, to providing personalized data services for ultra-rich people with smartwatches. Okay, all sorts of things. Neither of which I'm advocating as being good investment opportunities, by the way. So we're seeing lots and lots of different ways to close a business case. They're often addressing new and uncertain markets, okay, which makes our job very, very interesting. And then we're seeing this new approach to the space market or space industry, which is short life cycles for business cases. So we've got to be able to generate ideas, implement them, close them very, very quickly. got to be able to be quick to fail. We've got to be failure tolerant as well. So we've got to be very, very happy to invest in things and just see it all just disappear and fizzle out. And we've got to be able to address new low-cost approaches to creating new services. And this is something that we're prioritising within the agency is, okay, small sats are cheap. We said that right at the beginning, right? Low cost. Can we make them even cheaper? And that is a challenge that we're setting ourselves. If we made them an order of magnitude cheaper still, we expect to see an order of magnitude more applications appear. We expect to grow the market that way. We went out to industry and we polled them. It's a very busy slide. I think these slides are being made available afterwards, so I won't go through this necessarily, but I will point out a couple of the highlights. If you have a look at what small satellite services or service providers want, they want low emission cost. Okay, everybody doesn't want to pay, okay, it's a no-brainer. You want to lower the cost of how much it costs to implement a mission, fine. They want reliability, okay? Now this is not necessarily just platform reliability, being able to switch your spacecraft on and have it switched on for 5 years or however long it needs to be in orbit. But this is reliability of end-to-end services. It's reliability of data delivery, okay? It encompasses many, many different things. They want agility, so this is the ability to get faster to market. They want to be able to go into orbits that they want to go into, rather than ones that they're forced to go into. They want mission elements as a service. Everything has to be kind of like Amazon these days, where you can just log on, I'm going to buy that launcher, I'm going to buy that ground provider, I'm going to buy that platform and this SDR, I'm going to plug it all together and just launch it, okay? They want agile project management methods. What we do see is we see an awful lot of companies coming to us saying that they're going to implement agile project management. And we have to step back and make sure that they've got actual proper, rigorous agile project management, not just chaotic management, which is kind of, unfortunately, the majority of what we see. And again, the agency can provide some guidance on that. And also they want performance. They want higher capacity payloads, higher capacity platforms. They want huge numbers of satellites being produced. A lot of these business cases rely on hundreds and hundreds of satellites. And when you go to people like CloudSpace and say, give me 300 satellites, and they go, well, okay, that's a bit of a challenge. It actually takes a lot of effort to put together a satellite, and you've got to develop new manufacturing techniques, similar to what they've done with OneWeb, where you can serially produce platform after platform after platform. And also, for our guys, for LEO satellites, we need a more modern approach to spectrum management. Okay. Access to FSS bands, which have been predominantly reserved for GEO, would be great. So we extract out various technology developments, we promote those within the agency and outside the agency, we fund industry to do these things. I've thrown up a few things here in terms of what we're promoting at the moment. Optical communications is excellent. So this is laser comms. Not necessarily the right audience for this at the moment, okay? But still, that is an upcoming trend. Optical communications for data downlink and also for inter-satellite communications. Inter-satellite communications, again, is something that we are desperately in need of. So this is where two satellites can communicate to each other using either RF or optical means. And we've got quite a few terminals in development to support this, but we have very few products on the market where you can go out and buy an ISL, a satellite link, to connect your satellites. And when you start talking about hundreds of satellites in the constellation, the ability to make your satellites talk to each other is a huge enabler for opening up new markets and new businesses. We want flat panels, antennas, both up there in space and also on the ground. One of the big things that holds back a lot of the applications that we want to see happen is cheap ground terminals. So beam steering flat panel antennas on the ground that can be deployed across the nation, provide you with direct access to satellite communications. That, if you can do that, if you can manufacture that so that it is done cheaply, then you've got a massive, massive market. That was 1/3 of the space industry, by the way. That was, was the ground side of things. And actually, that's one of the weaknesses we see in a lot of the businesses for the mega constellations. So people like SpaceX with Starlink, we haven't seen their ground terminal. If you guys have got any information on that, we're welcome to having a chat. We assume that they haven't ignored that side of things, and they're not just going to launch, 3,000-5,000 satellites just for the fun of it. But still, maybe. What other things? Developments in software-defined radio. Okay, they're actually getting quite advanced with these smaller payloads, but we can stretch their limits. More efficient RF front ends is now an area that we're focusing on as well. Maybe going back to analog front ends for very specific business applications to try and drive that power requirements down. What we're seeing is we're moving away from experimenting and just seeing, can we do it, into let's do it efficiently with these same platforms. Okay. Right. And I did promise my boss, who's paying for me to come here, to do a small plug for ARTES. Okay. Now, you are one of our target demographics, and we would welcome future involvement on projects that you find interesting, so new developments. So it is good to know of what we are and what we do. So ARTES is the Advanced Research in Telecommunication Systems. As I said before, we support competitiveness, so we support new developments, studies into things that will make telecoms industry in Europe better. Okay. We are supported by national delegate funding. So the nations all contribute money into ESA. ARTES is an optional program. UK supports us very, very well. We're yet to see how well they'll support in the next couple of months, but we anticipate very well well, I'm not talking about Brexit in this case. I'm talking about the ESA ministerial that's coming up, where they signed a cheque for the next few years. I will put your mind at rest that ESA does not get kicked out of UK come, I don't know what the next date is it the 1st of November? Yeah. Yeah. Support for ESA is agnostic of the European Union. Yep. We work with industry and institutions, and we sit there in the middle and support and manage the risk. And sometimes people look at risk and they just see money, okay? And that is one of the risks. Is we manage the financial risk, so we give support, financial support, but we also manage some of the technical risk as well and project management risk, because ESA has got roughly 3,000 employees, most of which have got a technical background of some sort. We have huge technical facilities and experience within all sorts of areas of development, and we can bring that to bear and support any developments that you guys want to do. Okay, we issue financial support, everything ranging from 100% funded activities, woohoo, yep, okay, to co-funded activities. We prefer co-funded activities, frankly, because if you are putting money in, we believe that you think that you're doing something of worth, okay? If you've got skin in the game, then typically it's a better project all round. Within the small sat guys in ESA, we are cuddly, friendly people, okay? We don't ram what are called the ECSS, so the space standards down your throat. We're quite happy to adopt your method of project management, work with your project at the pace that you want to do it, as long as it is rigorous enough to be demonstrated to be real. Okay. Okay. If you ever want to talk about funding, I will leave some business cards around. Drop us a line. We have all sorts of products, if you want to think of them that way, that fit all sorts of different needs. So everything from definition studies. Wouldn't it be great if we started using terahertz, okay, for communication in space? Let's do a study on that. Actually, we did do a study on that, but okay, fine. So that would be probably in the realms of FP, so future preparation or advanced technology. We can do definition studies saying, hey, I've got a fantastic idea for a new SDR. We're going to make it radiation tolerant so we can send it to IO. Cool, right, let's do that. We can do technology development where we actually build the breadboards and kind of play around with the circuits on the table. We can do product development where we package it together and actually make it look like it might fly in space. And we can do a demonstration where we actually put it into space. And all of these things we can help fund and support, which is really, really exciting. We also do things called pioneer projects. Pioneer projects are space mission providers, and we have a number of these, where if you come with a PCB that you want to fly, we can find a host that will take that and take away all of the complexity of trying to put something into space. So they'll do the space qualification, they'll do the hosting on a platform, they'll deliver the data back, they'll launch it, they'll do everything. You just come with your payload. Okay. So we do all sorts of things. So we develop equipment or help equipment being developed. We establish space mission providers that help put it in space. We help fly hosted payloads on big platforms. If you want to put a payload on a big GEO bird, we can probably help sort you out with that as well. We support the small sat side of things, and we also provide some elements of regulatory support. Okay. Again, I'm not going to go through this particular slide. I'll leave that with you, but that's a snapshot of some of the activities we've supported in the recent past. And again, this pulls them out in a little bit more detail. And we deal with everything from the Tinker Toy type, Tom's not here, pocket cubes, where you're really, really kind of pushing the bits out one at a time, to quite large developments that support future geocomms missions. Okay, and we're investing huge amounts of money. So that's the last point I want to make. Roughly about 30 million have been invested recently into small satellite developments. We have got 3 advanced technology activities with 3 more planned. We've got more than 10 running with developing actual products, and we've got 6 in-orbit demonstrations on the go at the moment. So this is going to leave you with just an open call. If you've got a good idea, you think it might have some commercial relevance in the future, and you want a little bit of support, technical or financial or otherwise, feel free to come talk to us. And we'll have a very interesting conversation at the very least. And I think that is me done. Okay. All right, so thank you.
Thank you for that very interesting talk. It's certainly a period of quite dramatic change in the commercial sector. Do we have any questions? Yes, David.
Yes.
Okay, thank you, Trevor. Thank you very much for a very business-oriented presentation, virtually 100%. You've identified a few risks, and if we look at a business analysis here, you've spotted a few things about bigger players possibly undermining the market for operators in LEO. The one thing that I haven't seen in your presentation is the risk to business from increased regulation. You've spoken about putting lots of satellites into orbits, huge constellations, reducing cost. Almost all of your presentation was looking at easy access to space and making it cheap. But in a global, with space being a globally accessible place, global regulation seems to be way behind the curve on development. Is there a risk to business from people saying, look, there's just too much stuff up there, one serious accident, and we're going to shut it all down?
I would actually say it's not necessarily just a risk, it's a constraint. It is currently constraining the future businesses in space. Our ability to deal with regulation, both in terms of spectrum, but also in terms of the actual satellites themselves in orbit, currently constraining what people are considering doing with satellites in orbit. So, I mean, spectrum management and regulation, okay, is one topic, and it is actually a very active discussion that's going on right now in terms of how better to support LEO telecoms missions. The other side of things, which is the actual regulation of the satellites in orbit, and I think you mentioned that, you know, if there's an accident, okay, what happens? That is something that there is no global consensus of. the US have a particular attitude to what happens with things in orbit. Here in Europe, we have a slightly more stringent approach. Okay. So for instance, if you were to do an activity where you want to do demonstration in orbit with ESA, you would have to comply with our clean space regulations. So you have to have end-of-life disposal plans, you have to do your debris mitigation, you have to be able to show that you demise on orbit, on re-entry, so when you come back in, you burn up and you don't leave a big lump of metal hitting some granny on the head. So you have to comply with all of these things. That still isn't moving with the times, okay? Because we've been dealing with, what, a couple thousand active satellites in orbit. We're seeing businesses that are proposing to put equal numbers into orbit, and not into just, you know, all the orbits that we got, into one orbit, one altitude. And this is a very, very interesting, yeah, I'm going to use that term, okay, yeah, interesting scenario, where, yeah, we have this potential situation where there could be destructive events that create debris belts. And yeah, okay, regulation hasn't caught up. It is an area that we've identified as being a priority. We have internally a study going where we want to consider what is the advice that we give to telecoms guys. How many satellites do you put into a particular orbit? What is the relationship between the platform reliability that you can demonstrate and the number that you put up there? Okay, and this is the type of guidance that we can need to put in place. Unfortunately, though, orbit access is an open access market. We can't provide global regulation. Okay, it comes down to space law. We can't do that. What we can do is we can try and be the best space citizens possible. Okay, and here within Europe, we can regulate to some degree. We have control over that particular market, but we can't impose that across the board. So it is a scary time. Okay.
Thank you. Question over there.
Yes, great presentation. Thank you very much. I've got a beard.
Yep.
I used to be a suit.
Fantastic.
I left it at home because you can't wear a suit here. It's ridiculous. If I had a really good idea, and you know, I'm pretty experienced in the innovation process, I want to have some very skilled systems engineering thinkers with particular expertise in some of the disciplines needed. But I'm going to have a hell of a job finding them, because there aren't too many universities and other organisations that produce that sort of graduate. What can you do to help?
That's an interesting question there. Personal challenge, fair enough. So, full declaration, I wasn't always in the agency, okay? So until about 1.5 years ago, I was an academic. I was an academic for 10 years. Teaching space systems engineering. So I taught at the International Space University. I taught at Kingston University, just down the road from where I currently live, University of New South Wales, down in Sydney, ESA in France and in Toulouse, and always in kind of the systems engineering. So I fully agree with your assessment, which is that we need more systems engineers. I see that, yeah, systems engineers are the glue that hold a particular project together. Okay, engineering, that's easy. Okay, but yeah, systems engineering, that's hard. What we do within the agency, okay, is we don't have a huge amount of structured mechanisms for promoting this. We do support universities in certain missions. Okay, that's fine. So we have particular levels of support for universities, typically much more favourable than for industry itself. So within ARTES, so we can provide funding. In terms of creating more courses, we don't really step into that, okay? If there is a need for courses to be developed, both from a student desire point of view and also an industry point of view, we let the universities operate as a business and respond to market forces in that regard. They're not necessarily responding very well, but we don't have the tools and the mechanisms to kind of push so well in that regard. Otherwise, we do activities, so my colleague Frank Seppenfeld, who some of you have met and know, he's a kind of a very engaged person with the amateur and the academic side of things, and we regularly kind of push projects which are aimed to support those types of activities. So he's running a maker space type activity. Sorry? Yeah, we have an education office, okay, but not necessarily targeting systems engineering development. But yes, thank you very much. Yeah. So we have a number of different activities that run out of the education office. We have Fly Your Thesis, which is a parabolic flight opportunity. We have Drop Your Thesis, which is a microgravity drop one. Those ones are very well funded by the science side of ESA. We have also an activity of putting your thesis or your CubeSat into space as well, which is currently running. Yep. We have OPSAT as well. Very good. Yeah. OPSAT is an interesting beast. I could talk a little bit longer about that, but I suspect I shouldn't. Yeah. So there are the variety of different activities, but within ARTES, which is commercially focused, we are somewhat constrained.
Okay, thank you. Just time for one very brief question.
I also like to thank you for your very fine presentation. My background is regulator, so I would like to continue this discussion. Your presentation shows that there will be a lot of many new satellites or constellation of satellites in the orbiting area. Now you are familiar with the Aalto-1 CubeSat. It has two instruments and one system that should bring it down when its useful lifetime is end. Mm-hmm. You said that regulation is going very slowly forward, but do you foresee in the far future that kind of system which Aalto-1 has or similar systems will be needed? Thank you.
So, just like to clarify so it's a data on demand type system is what you're saying, is it? Or
it's a system that will bring it down when its useful lifetime is ended.
Oh, okay. So deorbiting, right? Okay. So we're on the satellite management. Yes. So deorbit is something that is incredibly important. It's one of the 7 kind of key activities of clean space within ESA, is deorbiting things successfully. There are significant challenges, and it's one of the reasons why a lot of our CubeSats go into LEO, is because that we have to say, right, we've got confidence that they come back within 25 years, and we don't have necessarily off-the-shelf deorbiting devices that we can use to be able to push them higher. A lot of deorbiting devices rely on things like deployable sails or tethers and so on, which only increases the margin for height that you can go by several hundred kilometers, but you're still in LEO. It depends very much on the ballistic coefficient of the spacecraft. Yeah. 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 So that's what we have to concentrate on. I think the real challenge, though, is we want to break out of LEO. I'm personally a believer in getting CubeSats into GEO, but we can't rely on those types of deorbiting devices out there. It's not going to do anything. So you need reliable systems. So you need a reliable platform that has got reliable propulsion on board to be able to get you outside into a graveyard orbit. And this is the challenge. Challenge is to have something that you can put out there that will stay up and be responsive to a deorbiting command after 5-10 years, whenever your mission is finished, and be able to put you outside of those operational orbits. In MEO, I don't care so much. It's not protected. It's a big space as well, and yeah, fine. Okay, but in GEO, that I think is where the real challenge is. Okay, yes. Okay.
I'll have to wind it up at this point. I'm sure Dr. Osborne will be pleased to answer any further questions after the meeting. We now bring this particular session to an end. We'll resume in 20 minutes' time at 10:45. Thank you.
Super. Thank you.